Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0641, indicates a malfunction related to the sensor reference voltage A in a Honda Accord from the years 2017 to 2023. This code is primarily associated with the Powertrain Control Module, PCM, and its ability to provide the necessary reference voltage for various sensors. A functioning reference voltage is critical as it ensures proper sensor operation, affecting engine performance and efficiency. When this DTC is triggered, it signifies that the PCM has detected an anomaly in the voltage reference supplied to several critical sensors, which may lead to improper readings and potential vehicle malfunctions. Understanding the nature of this fault is crucial for conducting an effective troubleshooting process. This presentation will guide you through identifying the components involved, possible causes, and systematic troubleshooting steps to resolve the issue. DTC P0641 involves the Powertrain Control Module, PCM, the brain of the vehicle's engine management system. The PCM is responsible for generating the reference voltage that powers various sensors, including the crankshaft position, CKP sensor, the manifold absolute pressure, MAP sensor, the fuel rail pressure sensor, the camshaft position, CMP sensor B, output shaft speed sensor, neutral position sensor, throttle body, and accelerator pedal position, APP sensor. These sensors are integral to the vehicle's performance, providing essential data for engine timing, fuel delivery, and throttle control. The CKP sensor detects the position of the crankshaft, while the MAP sensor measures the intake manifold pressure, crucial for calculating air-fuel mixture. The CMP sensor B tracks camshaft position, and the APP sensor provides feedback on accelerator input. Each component is typically located around the engine and any malfunction in the reference voltage can result in inaccurate readings and vehicle performance issues. Several factors can lead to DTC P0641 being triggered. One primary cause could be poor electrical connections, particularly at the connectors leading to the affected sensors. Corrosion, dirt, or damage at the terminals can significantly impact the ability of the PCM to deliver the correct reference voltage. Loose terminals can also disrupt the electrical flow, leading to fluctuating voltage levels that fail to meet operational standards. Additionally, if any sensor that the PCM relies on is malfunctioning or shorted, it can compromise the entire reference voltage system. This highlights the importance of thoroughly inspecting connections for wear and ensuring the integrity of all related components. Understanding these potential causes can provide a swift path to diagnosis and repair. When DTC P0641 is present, drivers may observe several symptoms indicating engine performance issues. One of the most immediate signs is the illumination of the check engine light, CEL, on the dashboard, alerting the driver to a fault in the engine management system. Additionally, there may be noticeable poor acceleration, as the vehicle may struggle to respond appropriately during throttle application due to incorrect sensor reading. Other potential symptoms include erratic engine behavior, such as stalling or rough idling, which can stem from compromised fuel delivery or timing caused by the malfunctioning sensors. Overall, these symptoms not only affect drivability, but can also lead to further engine damage if left unaddressed. The first troubleshooting step for addressing DTC P0641 is to ensure the vehicle is in the on mode, ensuring the electrical systems are active and capable of diagnostics. Using the Honda Diagnostic System, HDS, the next action is to clear any DTCs that may be currently stored in the PCM's memory. This process resets the system, which can sometimes clear transient faults. After clearing, It's crucial to check for any pending or confirmed DTCs with the HDS. If DTC P0641 is indicated as confirmed, it suggests a persistent issue that requires further inspection. If it does not appear, the vehicle may have experienced an intermittent failure, suggesting a need to check for poor connections or loose terminals at the PCM and sensor connections. In the second troubleshooting step, the focus shifts to determining the possible failure area related to the vehicle's reference voltage circuit. Begin by turning the vehicle to the off mode before disconnecting several critical connectors, including the CKP sensor, MAP sensor, fuel rail pressure sensor, CMP sensor B, output shaft speed sensor, neutral position sensor, throttle body, and APP sensor. Each connector should be disconnected carefully to prevent any damage. Once these connectors are removed, turn the vehicle back to the on mode to activate the diagnostic systems. Afterward, utilize the HDS again to check for any pending or confirmed DTCs. If DTC P0641 appears, it indicates an issue with one of the disconnected components. If not, further testing will be necessary to locate the fault. Step 3 involves conducting a shorted part check by reconnecting each sensor one at a time while monitoring for the return of DTC P0641. This methodical approach allows for isolating which component may be causing the error. Begin reconnecting the sensors, starting with the CKP sensor, followed by the remaining sensors in order. After each reconnection, check with the HDS for any presence of DTC P0641. If the DTC reappears after a particular sensor is reconnected, that component is likely faulty and should be replaced. If DTC P0641 does not trigger upon the reconnection of any sensor, a thorough check of the connections and terminals at the PCM and all previously disconnected components is recommended. In the fourth step, the objective shifts to performing a shorted wire check concerning the VCC lines to power. After turning the vehicle to the off mode, jump the SCS line using the HDS and allow it to sit for over 1 minute. Following this, disconnect both PCM connectors A and E, which serve as critical communication and power supply pathways to various sensors. Once the connectors are disconnected, turn the vehicle back to the on mode and measure the voltage between the specified test points and body ground. These measurements should be taken individually at the CKP sensor connector, MAP sensor connector, and others listed in the diagnostic process. If voltage is detected at the test points, there is a short to power in the VCC line, necessitating repair. If no voltage is present, proceed to the next step. The final troubleshooting step involves checking for shorts in the VCC wires to ground. Again, begin by turning the vehicle to the off mode, which ensures the circuits are not live and safe to handle. Assess continuity between the critical test points and body ground for each sensor and PCM terminal listed. Each measurement should be conducted carefully to ensure accurate readings. Should any continuity be detected, this signifies that there is a short to ground which needs immediate attention and repair. If no continuity is found, it suggests that the VCC wiring is intact, and further diagnostic procedures, such as consulting authorized service information or substituting with a known good PCM, may be necessary to continue troubleshooting. After completing all necessary repairs, the final verification step is essential to confirm that the DTC has been resolved. Begin by using the HDS to clear any DTCs stored in the PCM. Following this, conduct a test drive to evaluate the vehicle's performance and ensure that all systems are functioning as expected. During the test drive, Pay close attention to the responsiveness of the vehicle, ensuring that the acceleration is smooth and that the check engine light does not illuminate again. It's vital to monitor for any abnormal behavior or symptoms that were previously noted. If all systems operate correctly and no part failures are detected, you can confidently conclude that the issue related to DTC P0641 has been successfully addressed. Preventive maintenance plays a crucial role in avoiding issues like DTC P0641 in the future. Regular inspection of all critical sensors, including the CKP, MAP, and APP sensors, can help identify wear or damage before they lead to major failure. Routine checks of electrical connections are also vital. Ensure that all terminals are clean, secure, and free from corrosion. Additionally, it's beneficial to keep the PCM software updated to ensure optimal performance and compatibility with the latest vehicle parameters. Implementing these preventive measures helps maintain stability in the reference voltage system and can greatly reduce the likelihood of encountering DTCs in the future. In conclusion, effectively addressing DTC P0641, which signifies a sensor reference voltage A malfunction, involves understanding the underlying components, possible causes, and systematic troubleshooting procedures. By following each step diligently, from verifying the issue, checking sensor connections, to conducting thorough voltage tests, you can isolate and repair the problem efficiently. It's essential to monitor vehicle symptoms, perform necessary repair, and conduct final verification tests to ensure that the DTC is resolved. Furthermore, implementing preventive maintenance strategies safeguards against future occurrences of this DTC. With the right knowledge and approach, you can ensure that your Honda Accord operates smoothly and reliably. Please like and subscribe to the channel. See you next time.